Present now. Share. Okay, can you guys see?
Yeah.
Can you see it?
Yeah.
Yeah, okay. And where did I lose you? When did the power go off for me? Were we done this one?
Yeah, you were just asking questions if anyone didn't understand y equals mx plus b.
Okay. Sorry, just my husband's he just got home. Just give me a second, guys. Yep, the power's off.
I know. You want to go to school? It's going to be off to 1 o'clock.
I'm almost done the lesson and I'm using my phone as a hotspot. Is that okay?
Oh, okay.
Okay,
Yeah.
I figured it out. Okay, thanks. That's okay. All right, so did anyone have any questions about that part?
I just have, do you have to show all that work right there? Or can you, like for the y equals mx plus b?
What parts do you not want to show? Do you just want to show like here and then you've got b out right away?
Yeah, can you show that you substituted it and then go to the answer?
Yes.
Okay.
Any other questions on that part? Okay. All right. We will go to the next one. Okay, so the next question mathematicians asked was, what if I wanted to find the slope of the tangent at a bunch of places? So not just one x value, but I wanted to show it maybe at 30, depending on the function, right? You don't want to have to do that process 30 times for 30 different x values. So their question was, do I really have to use the first principles formula 4 different times for x equals 1, 2, 3, and 4? Or can I find a general formula for the slope of the tangent to the curve at a general point? So our general point would be, our a is going to just be x, so any point x, and then the corresponding y value would be, when you sub x in, you get x squared minus 4x minus 3. And the answer is yes, you can do that. So you can make a formula, and that formula will give you the slope of the tangent at that specific function. It would be called the derivative function, and it requires us to use different notation to express the slope of a tangent. So note that f prime at x means you're finding the slope of a tangent at a general point. So at any point or a general point x, not at a specific point a. Okay, so the slope of the tangent to a function y equals f at x at the point x f at x is also called the derivative of f at x with respect to x, and is given by this formula. So this is an important formula. This is our two things. So it's the derivative formula, and it's also the slope of the tangent at a general point formula. So we've learned kind of 3 formulas today, although I would say to you that these 2 formulas are the same formula. They're just written differently. Okay, so the first 2 we learned are to find it at a specific point, and they both mean the same thing. And then this is the one we would use if we're finding it at x. Okay, if we just want to find f prime at x, or the derivative at a general point x. So the slope of the tangent, okay, so we're going to go ahead and do it for this curve here. So what do we need? We need f at x, which we have. So our f at x is x squared minus 4x minus 3. F at x plus h, though, is more intense algebra. So that means I'm going to replace x with x plus h. I know it's a bit dimmer to see. I'm sorry, it's because I don't have any other light because the power's off. But my camera is attached to the computer, so that's the only light you've got right now. Try to keep it under that light as best I can. All right, so now we've got to simplify this as much as we can here. So x plus h squared, if you can square a binomial in your head, great. If not, you're gonna have to write it out twice and use FOIL. There, we're going to distribute. Okay, so here's where we use our FOIL. We can't square a binomial in our head. So we get x squared plus xh plus hx is another xh plus h squared. Collect like terms here. So I'm looking x squared, there's no other x squared term. Xh, there's just two of those, so plus 2xh. No other h squared term. And minus 4x, minus 4h, minus 3. So once you've got no like terms, that's the best you're going to be able to do. Any questions on expanding that part out? Everybody okay? Can you hear me?
All good.
Yeah.
Yes, okay, good. All right, so now we're going to go back to our formula. So f prime at x is going to be the limit as h approaches 0 of f at x plus h. So that's all these terms. Be really careful that you don't miss one. I've done that before. So x squared plus 2xh plus h squared minus 4x minus 4h minus 3. So all of that was f at x plus h. Now we want to subtract f at x, and f at x has 3 terms in it, so I need those brackets there. They're so important because I'm not just subtracting whatever comes first, I'm subtracting everything in the bracket. So you have to show those brackets all over h. And then your next step is going to be to distribute that negative. So careful here when you multiply the -1 by -4x, you're going to get positive 4x, and -1 by -3, you're going to get positive 3. So once you've done all that work, which is a ton, I know, here comes the fun part. So you get to create 0 pairs and get rid of a whole bunch of terms in the numerator. So we've got x squared and negative x squared, 0 pair. We still need our positive 2xh, our h squared, but we've got minus 4x and plus 4x, so those are gone. Minus 4h still there, minus 3 and plus 3 are gone. So what we're left with in the numerator, and this should happen every term you're left with in the numerator, should have an h in it because we want to be able to factor that h out eventually. So that's how you'll kind of know if you're on the right track here. So I've got 2xh plus h squared minus 4h. And that's all I've got left. Yep, over h. So now I can common factor that h out of the numerator. Divide out the h, so I'm left with f prime at x equals the limit as h approaches 0 of 2x plus h minus 4. So again, we just made a formula that will let us find the slope of the tangent anywhere we want at any x value on this curve. Okay, so that's what that formula means. It's like a slope of the tangent formula or the derivative formula. So that's for this specific function over here. F at x equals x squared minus 4x minus 3. So we want to find it at 1, 2, 3, and 4. It's set at the beginning. So f prime at 1, for instance, would be the limit as h. Oh no, sorry, my bad, guys. There should no be a limit there anymore, right? Oh no, there should be. I'm just not done yet. Okay, I can still keep going. I can take the limit as h approaches 0 because there's no h in the denominator. So f prime at x. So now we're going to take the limit, let h approach 0, and I'm just going to be left with, so 2x doesn't depend on h, so that stays. H is going to approach 0, so I'm just left with f prime at x is 2x minus 4. This is my formula for the slope of the tangent for anywhere on that curve. F prime at x is equal to 2x minus 4. All right, so once you've made that little formula, if you want to find f prime at 1, which would be the slope of the tangent where x is 1, you would just, we'd just sub 1 in for x. So that should mean that if you look at your graph here, where's x1? Right here. There's my point where x is 1. It should look like the slope of the tangent should be -2. It does look like it would be negative, fairly steep. -2 looks good for there. F prime at 2 would be 2 times 2 minus 4, or 4 minus 4, which is 0. Okay, so where is 2? There's an x of 2, and it's right at the bottom of a valley. So you would expect to have a horizontal tangent. Okay, so that again makes sense to be the slope of the tangent. When x is 2, when x is 3, the slope of the tangent would be 2 times 3 minus 4, which is +2. So x being 1, 2, 3, there's my corresponding y value. And it does make sense that the slope of the tangent would be 2 there. Okay, so that's why you would find the derivative in terms of x if you needed to find the slope in a bunch of different places, or if it just asked you to do that. Any questions about that? I know I kind of messed that ending up. Everybody good? Can you hear me?
Yep, we're good.
Yep.
Okay, we're good. All right, so let's go on to the next one. All right, so given f at x equals the root of 2x minus 3, find f prime at x. All right, so we're going to use our f prime at x formula. So f prime at x is going to equal the limit as h approaches 0 of f at x plus h minus f at x over h. And then we'll find those things. So f at x plus h, using this, is going to be the square root of 2 times x plus h minus 3, which is the square root of 2x plus 2h minus 3. There's no like terms there, so that's the best you can do. So f prime at x is going to be the limit as h approaches 0 of the root of 2x plus 2h minus 3 minus the root of 2x minus 3 all over h. And we cannot let h approach 0 because the bottom would approach 0. So we have to somehow free up this h from under here. And that would be by multiplying by the conjugate, top and bottom. Does anyone think they know what the conjugate for this numerator is going to be?
Same thing, but with a plus?
Yep, same thing, but with a plus. Perfect. So root of 2x plus 2h minus 3 plus root of 2x minus 3. And then we have to do the same thing to the bottom. Okay, and again, we want to do this whole FOIL idea here. And we're going to stick with that today till everyone really understands what happens when you multiply a conjugate. And then tomorrow when we move on, just doing limits for fun. Actually, no, it's going to be Thursday. Then we will talk more about what ends up happening. All right, so when we multiply first by first, we're multiplying two roots that are exactly the same underneath together. So we're just squaring it, which undoes the square root. So we're just left with 2x plus 2h minus 3. So there's our firsts. When we multiply our outsides, these root radicals are not the same underneath. So I just end up with a really ugly term that looks like this. So root 2x plus 2h minus 3. And then if you write another root directly beside it, it means multiplied by root of 2x minus 3. So it doesn't look pretty, but it just means these two multiplied together. That's my second multiplication. My third multiplication is these inners multiplied together. So it's going to be minus root of 2x minus 3 root of 2x plus 2h minus 3. And then the most important multiplication here, the one that you have to really think about here, when we multiply these two lasts together, we have a negative multiplying by a positive, so it means it's going to be negative or minus. And we've got two identical radicals multiplying together, so we'd end up squaring them, which undoes the square root, but we're subtracting the whole thing, so it has to be in brackets. So these brackets around that 2x minus 3 are really important. And then in the bottom, we aren't going to multiply these, like distribute at all. We're just going to leave it yucky. So h times this conjugate, 2x plus 2h minus 3, plus root of 2x plus 3. Everybody okay so far with those 4 multiplications?
Miss Northwood, I think you made a mistake on the bottom. The second square root should be a 2x minus 3.
Awesome, thank you. I'm so glad you guys are doing that, paying really careful attention to what I'm doing. All right, okay, so everybody see that these two terms here are a 0 pair? We have adding and then subtracting the exact same thing. So these yucky terms add up to 0. which is nice. So in the numerator, I'm left with 2x plus 2h minus 3. And then if I distribute this minus here, I'm going to get minus 2x plus 3 over h times root of 2x plus 2h minus 3 plus root of 2x minus 3. So then look for my zero pairs. So I've got 2x and minus 2x, minus 3 and plus 3. So after all that work, it's so nice. I end up with 2h in the numerator. And not as nice in the denominator, but it's going to allow me to divide out that problematic h in the bottom. So these can divide out, which is going to allow me to be able to let h approach 0. It's under the light here. So f prime at x is going to be the limit as h approaches 0 of 2 over this. There's actually a really pretty ending coming up here. So now we're able to let h approach 0. So as h approaches 0, it doesn't affect the numerator. There's no h in the numerator. In the denominator, I've got the root 2x plus 2h. So as h approaches 0, 2h approaches 0. So this is just going to become the root of 2x minus 3. And then this one doesn't have an h in it. It's not affected by h approaching 0. So it's going to stay root of 2x minus 3. So really, I'm adding 2 of the exact same thing in the denominator. So another way to write the denominator is 2 root 2x minus 3's. Which means that I can reduce this as 2 over 2, which is 1, over root of 2x minus 3. So the derivative actually, after all that work and complicated stuff, ends up looking pretty nice and simple. So the slope of the tangent anywhere can be found by substituting x in to the formula 1 over the square root of 2x minus 3. And if you look at the function we started with, f at x equals root of 2x minus 3, and the derivative is 1 over 2x minus 3 is really cool. Okay, so we answered the first part. We've got f prime at x. The second part wants us to find f prime at 2. So we take our f prime at x formula, replace x with 2. So that's 1 over the square root of 1, which is just 1. Which would mean that the slope of the tangent to that curve would be 1 when x is equal to 2. So this represents slope of tangent, remember. When x equals 2. That's what that actually means. Slope of the tangent is 1 when x equals 2. Any questions for that one? So remember the idea of finding f prime at x is we're getting a formula for the slope of the tangent so that then they could ask us to find the slope of the tangent anywhere, and we could just use that formula that we made to find it, especially if you have to find it at multiple places. Can we move on to the next one?
I still need time to copy things down.
Okay. If you are done, see if you can start setting up for the next one. This part here, knowing that what it actually means, that the slope of the tangent is 1 when x equals 2, is super important. Just for understanding what it is we're doing here.
Miss Northwood, why does 1 over root 1 just become 1?
Square root of 1 is 1, and 1 divided by 1 is 1.
Okay.
All right, guys, last question. Okay. If y equals 1 over 5x minus 1, A, find the derivative of the function. So when you see that, you're thinking f prime at x. B, find the derivative at the point when x equals 2/5. Okay. So as soon as you know that you have to find f prime at x, you're going to go ahead and write out that formula. So it's the limit as h approaches 0 of f at x plus h minus f at x over h. And then you need to find f at x plus h using the defining equation. So it's going to be 1 over 5 times x plus h minus 1, or 1 over 5x plus 5h minus 1. Then you're going to substitute in. So f at x plus h is 1 over 5x plus 5h minus 1. And just plain old f at x, y and f at x are the same, is going to be 1 over 5x minus 1. All over h. Just remember y and f at x can take each other's place. So now you have to subtract the fractions in the numerator by getting a common denominator. And we talked about having to multiply these to get a common denominator, so it's not going to be a pretty one, but it will be effective. So our common denominator is going to be 5x plus 5h minus 1 multiplied by 5x minus 1. And then my numerators have to be adjusted. So in this case, I had to multiply the bottom by 5x minus 1. So I have to multiply the top by 5x minus 1. And in the second case, I had to multiply the denominator by 5x plus 5h minus 1. So I have to multiply the top by the same thing. This is the important, I call it the star step. So this is where I want to subtract the entire numerator. So I'm going to leave it in brackets so that I remember to distribute that negative through all of the terms, not just what happens to come first. And at the same time, I'm going to, instead of dividing by h, I'm going to multiply by 1 over h. So I've got it down to 2 layers at least now. So on your next line down, you're going to want to distribute this negative through this bracket. So I'm going to get 5x minus 1 minus 5x minus 5h plus 1 over, I'm going to put this monomial h out front and then my trinomial and my binomial multiplying next to it, like that. And then again, when you're simplify the numerator, it should end up that you just have a term or terms with h in it, so that you can factor that h out to go with the h in the bottom. So it does turn out that way because I have 5x minus 5x and negative 1 plus 1. So all I'm left with in the numerator is negative 5h. And in the denominator, I have 3 terms here. Set to the light a bit here. All right, so now I can divide out that h. That's preventing me from allowing h to approach 0. And now it's safe to let h approach 0. So I'm going to take the limit. So as h approaches 0, the numerator negative 5 stays the same. As h approaches 0 in the denominator, this term approaches 0. So I'm just left with 5x minus 1 here, and then another 5x minus 1. And then a prettier way to write that would be that. Everyone okay for that? Finding f prime at x? Finding the derivative?
All good.
All good? Okay, so
Oh, yeah.
then our last part for the lesson, part B, is to find f prime at 2/5. Find the derivative at the point when x is 2/5. So that means f prime at 2/5. It actually is not as bad as it looks because when you multiply 5 by 2/5, your fraction disappears. So 5 times 2/5 is just 2. Two minus 1 is just 1. squared is 1. So you just end up getting that f prime at 2/5, which is what they asked for, the derivative at the point where x is 2/5. So therefore, f prime at 2/5 is equal to -5. If you're a little bit wobbly with fractions after the break here, 5 times 2/5 is 10/5, which is 2. Multiply the tops together and the bottoms together. And then again, I gave you a picture. So if you look up at your picture there, 2/5 is 0.4. So if we look at our graph, I'm not going to pull it down because I know people are still copying it down. But if you look at where x is 0.4, you look like you're going to have a pretty steep negative slope. So -5 definitely makes sense for the slope of the tangent to be -5 when x is 2/5, which is what that means again. And that is the lesson. So I use the textbook for practice questions. And you'll see that here. I've just taken them, snipped them from the book, and then I have answers at the bottom, and I'll post solutions. I'm hoping that my husband said power's not going to go on till 1, so my internet's not going to be back up till probably about 1:20. So I'll use my phone as a hotspot to get everything uploaded, and then I'll use my phone just to check for messages so I don't use all my Wi-Fi up. If anyone wants to stay on after I stop recording now to ask questions, that's fine. Other than that, try the practice. I'll put on I'll put the grade book thing for the assignment so you can upload it, even if I can't see it until after 1. And then message me with Edsby if you have questions, and I can always set up my hotspot again to answer them. All right, so I'm going to exit out of this. Is everybody good?
Still copying.
Feel like you're still copying? Okay, so wait. If you want to go, that's fine. And if not, wait for Carly to finish copying it down, and then I can answer any questions you've had.
Thanks, Ms. Northwood.
Thanks, guys.
Thank you.
Yep. Sorry about the power. Still copying, Carly?
Could I have the therefore statement for example 2?
Example 2. So like, yes. This one, f prime at 13.
Yeah.
Okay.
Okay, I have it now.
You have it now? Okay. All right. So I'm just going to stop recording. If anyone wants to stay on and ask questions, that's fine. Gotta go in here, stop recording.